I'm starting up the stream. Looks like we are live. Hi everyone, I'm TigerHawk23, and today we're going to fix the deck. Again. Because it was broken. Again. By me. Again. Anyway, I summarized it, kind of more than a summary, in the description, which you can check out at any time. But briefly, we're checking too early that a deck has been seen or not. So here's our string method. Repro is just string, it's fine. So we're going to join, and here's our handling recursion case. We have our Deque or whatever, and with the ... if it's a deck, and here's where the magic happens, but it's not the good kind of magic. We're going to use the recursive thing if we have seen this deck before, and if we have not seen this deck before, meaning this is falsy, we are going to add it to the scene set. So, yeah, that is too early. So if you have a deck that actually doesn't have any recursion in it, meaning like A equals Deque, and then A.append A, now you have recursion. Not even anything like that. You could do A equals Deque, and then B equals Deque, and then A.append B, and A.append B. And there's no recursion there. There's just two references to B within A. So with this, you would get, when you print out A, you would see an empty deck, and then the representation for recursion, because we've already seen B before. That's not what we want. And I went on a little journey of trying to figure out how the heck to do this. And first I looked for just solutions to the general computer science problem of doing this, and didn't really find anything. I found some basic stuff about recursion, which was not helpful, like how to reverse a string with recursion. That's great. And then I thought I would just see how CPython does it, because they solved it already. So I searched for the source for Python lists, and I found a source code file in C, and I saw references, this is all linked in the description, by the way. I saw references to the representation of list recursion with the ... an ellipsis, and I looked at the condition that would determine whether that should be used, and that was based on the result of a function call. And I googled the name of that function, because I didn't see it in that file. And that took me to a page on exception handling for the Python C API. And then I found the section on recursion control. It was getting warmer at that point. And then I found some C functions for recursion control, and one of them said basically equivalent to this Python thing in the standard library in reprolib. And it's that. It's this. This is the example they give for that. You have to import the thing first, but that's all you have to do. Notice how short this is. This is the repro, and it handles recursion. So if you want over here, you can have an object of class myList, and its repro, instead of being square bracket and then object, comma space, object, etc., square bracket, you would have an angle bracket, and then object bar, and then a closing angle bracket. And if it detects recursion, then it will use this. And that's it. Very easy. Did I close the thing where I was testing that? I didn't close it. Let's pop that up on the screen. Where is that? Is this the right one? Here we are. So lists, etc. Okay. Had to import that. So we import this method, and so we can use it as a decorator. And then we have that class myList, and then we do this, etc. And I'm going to move this over here so I can see what I'm doing. Having only one monitor really sucks, by the way. Anyway, that's the example that we got from that documentation. So we have our myList, which is an instance of a list, a subclass, and then we have A, then B, then C, and then we have M again, and then we have the character X. So we have, instead of a square bracket and then a string of A, comma space, string of B, etc., we have angle bracket, then the bar, and the bar, and the bar, and this is the default for recursive representation. Here I was actually testing the documentation says that a repro something object has a bunch of limits on the recursion level and the length of the string that it can create, but it seemed to work just fine. So I'm just gonna use that, just like the example says. And here we have this, and I passed it a string that I want to use, and we try that out, and indeed it does exactly that. So there we go. So that's something cool that we're gonna do. And here we go. After 8 minutes, we can start. This is one of those channels, by the way. Alright, first thing we're gonna do, we don't need that anymore. And this, I forgot something. Import multiprocessing, and we're going to import from reprolib, import, what's it called? The thing. Looking it up again. Import recursive repro. Also known as solve all my problems for me. Yes, take these problems and make them go away. Awesome. Okay, we've got that. We don't need scene anymore. Alright. Now we can just do something perfectly ordinary. We have to decorate it above our repro function, and then we just return the thing, and we don't have to worry about recursion. Awesome. This is actually going to be repro, because it's the recursive repro in reprolib, not string. So we're gonna clear out string basically and say just it's repro. And that's going to be of the class, which is... I did want that thing in there. How do we do that part? I want to refer... Basically, I want to do this. Type self.name. How do I do that from within the class? That's a good question, isn't it? Class, can I do that? Let's just, let's test this out with this thingy. Let's do this. Here we go. We're going to have a class, and we will call it A. Can we refer to class right in here? Class is not defined. Okay. Now, what do we have defined in the class? Class. These are things that we can access once we already have a reference to the class. I think I will actually just hard-code it, because how do I refer to a class within the class outside an instance? Refer to class name outside a method. That doesn't help. That doesn't help. That doesn't help. That doesn't help. Okay, never mind. Okay, so it won't solve all the problems. Whatever. Here's what we're gonna do. There. And then we do repro. Return Deque. It's going to be very similar to the example because it's kind of exactly what I want to do. Plus space dot join map repro self plus one of those, right? Join map repro self. Gonna do the same thing. That is a solved problem. And now I do return repro self. There. I'm gonna put this one before because I want to. Alrighty. Actually, let's go back to our this DV. Qual name. Aha. I wonder what the heck that is. But we're going to use it. By the way, this thing with locals, kind of like globals, never do this. Never utter these words. Locals and globals and global and non-local. Just don't. what I just did, you're not going to do that. I shouldn't have done that. I don't know if we can rely on this, but we're gonna, because I would rather do whatever this is than refer to than have a hard-coded name. So qual name, that's what we're gonna do. Without the quote. Qual name. All right. Okay. I still have this on, don't I? Okay. I don't know what that is. Let's Google it. I don't know what that is. PEP 3155 qualified name for classes and functions. It's in a PEP. It's fine. Python's introspection facilities have long had poor support for nested classes. Given a class object, it is impossible to know whether it was defined inside another class or at module top level. Blah, blah, blah. There's no unbound methods. C.f.m class. Possibility is gone in Python 3. Proposal the addition of a qual name for the qualified name. For top-level functions and classes, the qual name attribute is equal to the name attribute. For nested classes, it's a dotted path leading to the object from the module top level. Neat. A function's local namespace is represented in that dotted path by a component named locals. Alright. And this is PEP 3155. I will add that to the description. Let me make a note of this. Alright. I'm not proud of the way I found it, but I found it. That's what counts. Limitations. With nested functions and classes defined inside functions, I'm not doing any of that. The dotted path will not be walkable programmatically. That's fine. Excluding the module name. As name, qual name doesn't include the module name. That's fine. I just want Deque. Doesn't have to be deque.deque. Makes it independent of module aliasing and rebind it. Perfect. Allows it to compute at compile time. Perfect. Perfect. That's what I want. That's what we're doing. In chat, Zarek Simple Programming says, hello, what are you coding? We are fixing a mistake that I made earlier, and also another mistake. Several mistakes in a row piled on top of each other because I didn't know about a certain module in the standard library called reprolib, which we are going to use. And this thing over here is a Deque, a double-ended queue, implemented entirely in Python. And it's similar to collections.deque, only it's a lot slower because it's written in Python. But reversal is O of 1 instead of O of n, and plus is element-wise addition rather than concatenation. Concatenation is carried out with the call special method, and there's a whole bunch of element-wise stuff for every operator, and there's also matrix multiplication, because. Recursive repro qual name, Deque, plus join this, we don't have to worry about it, that, and repro instead. Alright, that should fix it. That should fix it. Save. And now we will do this. Okay. Let's test this out. shell so you can see what I'm doing. All right. Python from where this is stored. Okay. From Deque, import Deque as D. Okay. A equals Deque ABC. Oh yeah, I called it D. Right. Okay. We have a Deque of ABC. Whoops. I forgot there's supposed to be there's like let's try it again. Now, interesting point here about imports when you change stuff. If I just import Deque again, it will notice that I have already imported, and it will use the cached version, which we don't want because we changed it. So what we would do is we would import lib, and then there's a method somewhere in there that allows us to reload the module fully, bypass the cache. But the easy way to do it is by exiting and doing it again. Import this, and then what is A? Okay, good, good. So that's a good start. B is an empty Deque. And then in chat, Zurich Simple Programming says, "Oh, I think it's above my knowledge, but I enjoy following it." I'm glad to hear it. This is this stuff isn't actually way up there or anything, but it is part 19 or something. So there's a lot of other stuff that that if you missed might be weird to be able to keep up with, because yeah, it's a very large module now. How many lines is this? 1,179, and that's shorter than what it was before because we took out a whole bunch of nonsense. Let's go back to this. Testing equal D, A dot append B. Let's put another one in there. Let's look at A. We have ABC, empty Deque, empty Deque. Now let's say B dot append A. Let's look at A again. It's just Deque. Deque and then some stuff. Forgot. I forgot. There's more. So the representation of an empty Deque is now just Deque, because all we put for the thing is just the qual name, which is Deque. There's qual name plus there. That should fix its little red wagon. Okay. Good. Good. Here we are. We got a pen A. Empty Deque. Empty Deque. So then we have good. Cool. Solved. It is solved. So it avoids this problem with the... Actually, this would be the original problem of recursion. And this is not recursion, and it's fine. So let's see what collections.deque as E. Sorry. From collections import deque as E. What else do we have? What do we do? E equals no. Let's use I and J. I equals, by the way, don't do this with the single letter variable names. Awful. You will never be able to follow what in the world you are doing. So here we go. I'm going to keep doing that. I equals a deque that's ABC, and I is a deque of ABC. J is an empty deque. I'm just kind of doing this basically. B equals whatever. I dot append J. I dot append J. And then let's take a look at I. A, B, C, empty deque, empty deque. And then J dot append I. Now let's look at I. So ours goes Deque, ABC. This goes deque, ABC. And then we have a deque, parenthesis, square bracket, deque, parenthesis, square bracket. They have this as the representation. So it doesn't say it's a deque of some kind, it just says it's something. So they do not put the class name over there. Do we want to follow that, or do we want to specify, because this way it looks like a list. I guess it's implied that we would know what type it is, because if it's a different type, then it's not going to be the same object. And if it's not the same object, then it's not going to have recursion. It's not going to recur. So that's a decision we have to make. Should we include Deque, the class name, or not? I think we should include it because when you do it with a list, it contains the representation of the recurring list. When you do it with a deque, it does not. It has the same appearance. I don't know if it should do this. I suppose it's shorter to make it to make square bracket, ellipsis, square bracket. By the way, is it this or in the name ellipsis? Yeah, ellipsis. That's a thing. Of course, if you have a dot by itself, it will be very angry at you. If you have two dots by themselves, it will still be angry at you. But if you have another dot, then it's an ellipsis. I guess it's implied that square bracket dot 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 square bracket is how you can see that it is recurring. But square brackets are the list literal. So I don't know if I like that collections.deque uses the same thing. So here we have square bracket and then bracket, ellipsis, bracket, square bracket, because it's a list. Here we have deque, parenthesis, square bracket, and then bracket, ellipsis, bracket. And then, it is certainly implied. We just have to choose whether we want to have the same recursive representation as everything else, or whether we want to explicitly say that it is a recurring deque in particular. I think I want to leave it there with the qual name, this plus and the parentheses. I think I will leave those there. It's an interesting decision to be making. Should we have it there or not? As Wikipedia would say, primarily opinion-based. No, not Wikipedia. Stack Overflow would say that. Primarily opinion-based. Anyway, so this part is not going to be exactly like collections.deque, which uses the same representation for a recurring element as a list does, which I think makes it look like a recurring list literal. I think that's wrong. So mine is still going to say the name of this class so you know what type of object it is. Of course, you already would know what type of object it is. You just look at what it's contained within, and it's going to be the same type because it has the same identity. It's the same object. Actually, if you have, no, it would just be the, what if you have multiple types of things? Not e.append. I.append L. What do we got? Deque. So this is a deque that contains, only itself. B contains A. I, J, let's look at J. So we have I and J. J is A, B, C. There's the recurring thing. So that's the recursion happening there. That's the recursion happening there. Okay, so this is a deque, while this is a list. And we can tell because this is contained in the parent of this container, which is a deque. And this is a list because it's within the list. So that's just kind of how you can tell. L.append 5. Let's look at I again. So we have a list that contains a reference to itself and 5. Why am I y.append x. Let's look at x. Let's look at y. Same whatever thing. List within a list, etc. And I was so happy about finding qual name. Such a clever way of discovering it. Maybe I should have a vote with my viewers. I don't know if that's a... Can I make a poll and a card or something on YouTube? I don't remember whether that's a thing. YouTube poll cards, it's a thing. Okay. Maybe I will do that. I don't know. But what do I do for now, for right now? I like that the other way is shorter. And I think list and Deque are basically the only things with recursion where that can come up. A string isn't gonna, because it's just a bunch of characters. It's always flat. A dictionary, maybe it can be the value. Let's get some dictionaries up in here. How about M and N? M is a dictionary. By the way, this was the dictionary literal was introduced before the set literal, and because of this we don't have a set literal. You make an empty set by calling the set function. What they would have liked to do in hindsight is say that a dictionary is this, because, you know, it's key colon value, and the set would be like that, but it's too late. Anyway, N is another dictionary. M0 equals N. N0 equals M. Aha! Oh, now you see. Curly braces. Ah! Why does collections.deque use the same square brackets the list does? That's I don't know actually. Tuples are immutable. I guess I could have a list in a tuple. T equals that. T0 dot append T. What is T? Okay, I don't even know what I'm looking at anymore. I have a tuple, and inside that I have a list, that's correct, that holds a recursive reference to this tuple. Now this tuple is inside a list. So here we have a recursive dictionary with curly braces. Here we have a recursive tuple with parentheses. And we have a recursive list with square brackets. And here we have a recursive Deque with just square brackets. Qual name stays. Qual name stays. I didn't. One monitor, folks. I only have one monitor. So here's what we have. We have Dex, etc. Okay. What I tried was make dictionaries and then add each one as a value with any old key. I use 0 here. And so we have M is 0, holds the dictionary N, and N holds a key of 0 with the dictionary M, and that's recursive. So we have curly braces with an ellipsis inside. When we have a tuple, and we append that tuple itself to it, we have here a recursive tuple reference, which uses parentheses, which sort of defines a tuple. Tuples are really defined by the commas. See, works fine. The parentheses are used for grouping. That is one tuple. What if I wanted to have two tuples? One with 1 and 2, and one with 3 and 4? Then I would need to put parentheses around them. Grouping. But anyway, so the recursive representation is dependent on the type of object. Lists get square brackets, dictionaries get curly braces, tuples get parentheses. I don't know why Deque just uses square brackets without having the name of the class. But mine is going to. Mine is definitely going to. See? This is a recursive Deque. So that's what we've got. Alright. So, we made that decision. We solved this. Look how easy this was. We had to switch, repro and string, whatever. But instead of having a scene set at the top, here's what we replaced at the top. We took out the scene set and added this import. And now the repro is just appears naive. We have the beginning of the thing, and oh no, I need not Deque. Type self dot name plus. Okay, there we go. Cool. Here we for qual name. Great, great. Let's make sure that still works. D. Cool. Cool. Okay, so we don't have the name Deque hard-coded anywhere but the very top, which is okay because you have to call it something somewhere at some point. And we added this decorator for the thing we imported. Qual name plus, that's just going to be, Deque plus this is going to represent a recursive Deque, and I think that's fine. Type self.name, that's Deque, just the same as qual name, the qualified name, plus this, plus this. This is like the whole, this is kind of the outer wrapper thing. There's not actually really any logic in it, any algorithm that has to happen. This is where we get, stuff happening. And all we have to do is say, just map everything in here to repro. And if there's recursion, it'll handle it automatically with this decorator. I'm very pleased about that. That's good. Recursive repo and reprolib. Who would have thought that it's already there for people who want to do this sort of thing? So, simplified a lot. Very nice. I'm very happy with that. That should basically fix everything with the string method. It's just, there's not going to be any weird corner cases other than what would already be present, but hopefully that's basically nothing, because it's the standard implementation, so it better be good. So, that's good, that's it. Hopefully I will not find any more bugs the same way I found this one, which was waking up at 4 in the morning and thinking that string representation can't possibly work. But that's definitely fixed, because I did it the right way with the included battery. Python has batteries included. You will see this phrase here and there instead of reinventing the wheel. So that should basically take care of that, and if there is a problem with it, then it's not my problem. So that's cool. As far as features, I don't think there's anything else to add. So I think that's it for the deck. 19 parts. But of course, like I've said the last 5 times or so, I might still think of something that I want to change for whatever reason, something that seems cool to add, or something that was broken and needs to be fixed. But oh, I was also thinking before, maybe I can add some kind of C extension to hold maxlen and make it actually write once. But I consider that extremely optional. So if I look into it and it seems cool, then maybe. But if I look into it and it seems like a horrible mess, then no. And other than that, I think we're good. We're all set. I'm really happy that I found this. Very excellent. Okay, that is the stream for today. Other streams will be making maxlen actually write once with C stuff, if I feel like it. Probably won't. A graphical point of sale system, because the console one is basically a toy program, because cash register simulators are popular educational things, not for use for a real point of sale system. Anything with money you want to be very careful with, especially other people's money. And what else? Snake. Someone suggested Snake. Do I have their name? Pearl. Xeric Simple Programming made a comment on, it doesn't say which thing here, but person who is in chat here right now made a comment on another video last week suggesting Snake, and it sounded like a pretty good idea. Snake is reasonably simple, popular. There's another YouTube video on Snake with Python, but it's not Deque Enter, it's with curses. The kind of nicer-ish terminal emulator library to let you change characters at will instead of printing things over and over again. So it's with curses, and it doesn't have any kind of timer or anything, so you just kind of move the snake around at your own pace. Um, might do that, and some games. Mini Metro, maybe LOL or something. But that's what we've got for today. I hope you enjoyed the long and rambling story of how I found this stuff and how we implemented it. So I will see you next time. Remember to like, comment, subscribe. And happy coding. Have a good one.